And we're live.
Pretzels, butter, and sugar.
I'm just not into that. It's like a texture thing.
No, it's gonna pop.
Is it
I
moving?
used to love Jello.
I feel like it's moving.
Oh my.
I don't like
Just
Jello.
one day I was like eating it and like, I don't
Like,
like this
it doesn't have
anymore.
fruit in it.
Okay,
I don't know why, just.
Riley cannot move that desk.
Oh
though.
yeah, don't kick the desk.
She like violently
Takes her foot off it.
Ah, there it goes. Yeah, I called
Guess we could start the video over, so that doesn't need to be on there.
Ah, come on.
Okay, I'll just leave it.
It's not even getting the whole board.
It is. It's good.
Are you sure?
Yep.
I feel like you're getting half the bowl. There you go.
Oh. Alright. 5.5. So we're going to start with linearization.
Okay.
Nice part is you already know how to do it. Kind of. And then it's a little extra stuff.
So we won't understand it at all.
Yeah, you will. It's easy. I always
You told us the last one was easy.
You said this part's really easy.
Yeah.
Do you remember what locally linear means?
No.
Remember when we talked about that?
No.
We did. Pretty sure.
No, expand a little bit on it, maybe we'll remember.
It meant if you zoomed in far enough, it looks like a line.
Oh, yeah.
I don't remember
Or if
going
you
over
zoom
that,
out.
but I know that.
If you zoom out far enough, it gets like.
It looks like
It's
it looks like a parabola,
It's a little.
but then when you zoom in, it turns into a corner.
Yeah, sometimes there were corners and sometimes there were flat spots. Yeah. Well, that's a locally linear means just like. It just means if you like here.
If you look at a certain.
Gary calculator. Gary calculator. We're gonna do this. Whoop, not that one. That's from. Clear. Start over. So in your calculator, type in x squared plus 0.0001 to the 1/4 power. Make sure you put 1 divided by 4 in parentheses. Plus 0.9.
Is that it?
Wait. We good?
Good, grab
Ah.
it. Oh, except, time out. You're going to go zoom. And I've never used this one before, but zoom 4. Zoom decimal.
Raise to the what?
Go zoom 4.
Plus 0.9.
It's a cusp.
It's a cusp. If it was a cusp,
Yeah.
what do we know about that cusp? As far as
It changes from.
It is not
Concave
differentiable at that point.
it is not differentiable at that point. That's what I was looking for. Remember that? You can't do derivatives at corners?
Oh, yeah.
But let's see if this function is in fact differentiable at x equals 0. So here's my function. 0, 0, 0, 1. Come on, Dave, catch up. I'll slap you.
1/4 plus.
For YouTube video watchers, there's
An
This is
inside
start.
joke.
inside joke prior to that.
No, he's really sloppy. He's really going.
He's an abusive teacher.
Sarcasm.
Look,
I don't want him arrested.
That was stupid.
so if this is it shouldn't be differentiable at x equals 0, right? Let's check. Let's do the derivative of this.
Close parentheses plus.
So f prime of x will equal.
You don't have it still?
No, it expires in 25
Okay, I'm
hours.
gonna get what you're saying now.
You know, do the derivative.
Very careful.
Come on, this is good practice right here.
You have to do chain
End
roll.
it.
No, end it.
Chain roll.
Cole's going fast and furious on it. I think she's gonna get it. Or are you just catching up?
No, I was right
Doing the
in my
derivative?
head. Yeah, I got that in my head already.
With your head, Nicole?
Oh, not done.
Boom. Boom. Alright.
So 2, 1/2, so x. You should get that.
Got it.
It's 2/4.
Yeah.
It's 1/2.
Yeah.
Move that down.
I got it.
Okay. Is this differentiable at x equals 0? Plug in 0 for x. What do you get?
Oh, you get
You get 0 over
I
a
know.
number.
a number, which is 0. That's differentiable, isn't it? Oh, so is there actually a cusp there?
Probably not.
Oh, yeah.
Let's- Huh?
It's a little.
Let's go like this. Go zoom in, and then move it up to where y equals 1. And then hit enter, and it'll redraw it. And then you don't have to hit zoom in again. You just have to keep hitting enter, and it'll keep zooming in on that same spot. Yeah, I know. I was doing like zoom. I was like, what if it just works if you just keep pushing enter?
Oh, I see
Yeah,
it.
look at- Now it's a it's looking like a parabola, but if I hit it again, it's more like a parabola, but if I hit it again,
My
Mine froze.
calculator's
You know
like
you can
frozen.
pause it.
oh, that's you hit enter. Yeah,
If you hit enter while it's like
Yeah,
graphing,
I
it pauses
did know
it.
that.
I just figured that.
Oh, that's why it always freezes on me. Well,
Oh yeah, you could. Oh yeah, look at pause. Here,
How come it looks like a parabola? Oh, it's supposed to look like a
Keep going. Keep hitting enter.
Eventually you're gonna get a nice little flat line there.
Okay, what's happening?
Ooh, flat line, look at that. Cute.
Flat line, that's not good.
Yeah. Our graph flat line.
It's dead. Right, 'cause I'm just zooming in on that same point, really, really far,
It's just a.
until eventually now I have a straight line.
Boom.
It is locally linear. If I zoom in enough, it looks like a straight line. There's no corner there, right? And if I hit trace here, and I go over, look how much x is moving. 3.81 to the -6 power. That's 0.0000. I don't remember how many zeros I said. Right? There's 5 zeros. 0.0000381. I don't even know why. So it's barely moving over, right? So like on the grand scheme of things, it's really, really small. That's what local linearity is. It's just if I zoom in enough, it looks like a straight line. Right? So now we're going to use this idea.
For what?
For what?
What is the purpose?
To start, we're going to approximate square roots.
Even if you calculate.
So we're going to do the square root of 1.02 in our heads. Really? Not in our heads, but on the paper without the calculator. The graph of the tangent line would be what? What would the graph of the tangent line for this be? Or the equation of the tangent line? At this point.
Hey, I have a question.
Yes.
For every graph that's like that, if you always zoom in, it'll eventually be a straight line.
Not everyone. Like the absolute value graph, there's a corner there, and there's always a corner there, no matter how far you zoom in.
Live.
it's if it's a problem.
Parabolas, you can zoom in until they're linear. So what would the equation of the tangent line at this point be?
Y equals 1.
Yeah, just y equals 1. And yeah, there's the, that is your tangent line basically. It's itself when you zoom in that far. Okay, so the whole point of this is we're going to be able to say, well, let's just do the next problem.
Let's just.
So let's say we're going to be able to approximate the square root of 1.02 without a calculator.
Not good.
And the way we're going to be able to do that, what is the square root of 1.02? Really close to that, you know the square root of.
1.
The square root of 1. Inch is 1, right? Well, no. So,
2.
since we know, do you think the graph of the square root of 1, what would that be? That's just like the square root of x, right? At 1, at x equals 1. Do you suppose that's locally linear? Meaning for a while there, like if you were to take and graph the square root of x, you don't need to actually do this one. Now, if I go to the point x equals 1 and zoomed in and kept zooming in and zooming in and zooming in, what do you suppose would happen?
Should I?
Yeah, it would look like a line, right? And we could do that, but we don't have all day, so. It already almost does. Wow, it's already almost there. Doesn't it look like a straight line?
Yeah.
So if I want to know what the square root of 1.02 is, isn't that just barely to the right of that? So do you suppose if I knew the equation of that line right there, that would help? Because then, couldn't I just plug in 0.02 for x in my equation of that line, and that would just move me over a little bit? Do you see how that idea works? I'm not asking you to do anything yet, just think about that. So, we're going to do that. Well, how do I find the equation of this line?
Come on, gotta be students.
Yeah, isn't that the tangent line?
Or the mom.
Just I've zoomed in so far, it looks like a line, but isn't that the equation of the tangent line right there? Okay, so here's how we're going to do this. We're going to start, I know that's really close to 1, so my function that I'm going to use, or they call it a center point, is the square root of 1. And I'm going to do square root of 1 plus x. Because I want x to be 0.02, right? We'll work on how to figure that part out later. So now, if I can find the equation of the tangent line to that, then can I just plug in 0.02 for x, and that should give me what the square root of 1.02 is. See how that makes sense?
How do you feel like you're describing this?
Poorly.
We agree.
But if you plug in 1.02 right over, it would be like the square root of 2.2.
Let's ignore this part for a second.
No, he's plugging in 0.02.
Plugging in 0.02 for x.
Not yet. This is my equation that I'm going to use. Let's find the equation of the line tangent to this. Okay? So how do you do that? Yeah, you find the derivative. And we're going to go add x equals 0. So find the equation of the tangent line at x equals 0. Because wouldn't that be the square root of 1? So the derivative of that would be 1/2 1 plus x to the negative 1/2. which is 1 over 2 square root of 1 plus x. Alright, we're just finding the equation on the tangent line. You want to do this. If I plug in 0, my slope is square root of 1 times 2, it's a half. So I have y equals 1/2 x plus b. Or I guess we could do point slope form. Oh, what's my point? If x equals 0, what's y?
0.
1. If x equals 0, 1 plus 0.
Plug it in there.
Yeah, so I have 0, 1 as my point. Oh, so there is my y-intercept right there. So my equation of my tangent line is 1/2 x plus 1. Oops. Okay. So here's the graph of this. Square root of 1 plus x. Alright? I'm going to zoom in a little bit. There's the graph of it. Now, so if I plug in 0 for x, I get 1, right? Because the square root of 1 is 1. But I wanted to find the square root of 1.02. So wouldn't that be like plugging in 0.02 for x here?
Yeah.
And we said, don't if I zoom in on this enough?
Yeah, because should I?
Oops, I didn't zoom into the right spot. Yeah, we just said if I zoom in enough, it becomes a straight line. Right? So if I know the equation of that line,
I'm plugging in for x.
and if I'm only 0.02 off, like if I plug in 0, x is 0, okay, it's that. But now if I wanted 1.02, that'd be like plugging in 0.02 for x. Since it behaves like a straight line, couldn't I use this and just plug in 0.02 for x? Because my equation of my tangent line at that point is that straight line if I zoom in enough. And since we're so close to 0, you know, if I go over 0.02, do you think it's going to start curving yet, or is it going to look like a straight line?
Still gonna look like a
It's
straight
still going to look like a straight line pretty much. Does that help a little bit?
Mm-hmm.
So now this is my equation of my tangent line. But since I'm only 0.02 off from, 0, then I can just plug in 0.02 for x here. 1/2 times 0.02 plus 1. 1/2 times 0.02 is 0.01 plus 1. So I get 1.01. Well, let's see how close we were. What is the square root of 1.02? It's 1.00995. How close were we?
Pretty far off.
Pretty far off.
Depends how far back you
Look at it.
We were 0.00005 off, so we were 0.00005 off.
It's feeling precise.
That's pretty precise. I mean, that's pretty close, isn't it?
If you're machining something, pretty fast things.
Yeah.
Well, it depends on your unit of measurement. If you're using meters.
Yeah.
Yeah, only machining
If
in
you're using
meters.
miles, then you're way off. But if you're using decimeters, then
Machining a plant.
It's pretty golden.
And so they have a weird way of wording this. They say,
Yes.
how's that worded? So what is our error? The error, and this is weird, is less than
Ooh, your
let's see.
Because that place actually
1,
does
2,
make those.
3, 4, 5.
Do we have to write that?
So what if they try
Yeah.
to use this and then they're
I
off?
don't know.
Stop.
It's very cold in here.
And then the halo accident goes off.
Last time, you know when we were gonna get out of the,
Should do one more real quick.
you know when we were gonna get out of the, Mr. Russ is standing right at the door, like just standing like this, watching people. Did you see it?
In other words, for the other way.
Yeah,
So
no.
to do another one real quick.
Is that right?
He's like, they're off to the races or something like
Yeah,
So
so
I said
everybody
that we
complains
don't
about
want-
school lunch, but yeah, everybody runs to school. Don't.
that. Because they want to.
They don't wanna wait.
They want to.
All right, let's do one more real quick. So I'm gonna have you do this. In your homework, it'll say find the linearization of L of x at f of x at x equals a, blah, 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 blah. So basically, it looks like this.
So
They're gonna give you a
probably-
function, x, like this one's x plus 1 over x. And I say a equals 1. And it says, how accurate is the approximation for a plus 0.01? So they're saying find that, basically it's, here's this function. Find the tangent line at this point, and then plug in 0.01 for x, and see how close you would come if, you know, using the
So
tangent
find
line.
So
the
do like the errors,
Just like
and
that.
whatever.
Yeah.
Just do that.
So yeah, we find the derivative here. So that'd be 1. Let's see, that'd be x to the negative 1. So minus x to the negative second. So my derivative is 1 minus 1 over x squared. So my tangent line when a equals 1. Okay, so what would my point be? 1 comma 2. Make sense? So my, if I plug in 1 for x, what's my slope?
0.
Yeah, 1 minus 1 is 0. So what's my equation of my tangent line?
Y equals D.
Y equals 2 is my tangent line. So do I need to plug anything in? No. So this is saying, if I plug in 1.01 for x, my answer should be really close to 2. Right, since my tangent line is just y equals 2. Well, let's try that now. 1.01 plus 1.01 divided by 1.01. 2.0009901.
Again, not precise enough.
Not precise enough. So how close is my answer of 2?
Well, if you're constructing like
1, 2, 3.
Death Star,
1, 2, 3,
you know,
4,
any of those gigantic
9
things.
off. So you just say error.
Attention, all high school students. There are many
Yes.
kids in our community that won't get any gifts this
It's end
Christmas.
of the.
So do your part and bring some toys for the Migrant Leadership Club toy drive. Boxes have been placed in the library office, elementary office, administration office, and in Mrs. Becerra's room.
Think you can
Make
do
a
that?
child happy and bring a toy. Thank you.
The directions are confusing, but you're just doing this. And that's all 0.01.
What number is that?
5.5. There's some quick reviews so that when you get frustrated with these and you don't know what you're doing, you can do quick review 1 and 2. And regular numbers 1, 2, 5. So 1, 2, and 5, you're doing this process. It's called linearization. It's basically figuring out what it would be if it was just a line and then moving over just a little bit.
Have a good day, Nikki and Micah. Have a good day.
Someone text them and tell them this will be on there.
And Nikki, Micah, Micah.
No, it'll be under the date.